let's do another few examples of logs and natural log derivatives. If you look at example number 3 with me, it asks us to differentiate each of these functions. I have y equals the natural log of the absolute value of 5x. As soon as I see the natural log, I know that I'm going to do the derivative of the inside over the inside. The derivative of the inside, 5x is 5, over the original inside is 5x. I can reduce 5's and I can say that my derivative is 1 over x. All right, look at b. Be careful. On b, I have f of x is equal to 3x times the natural log of x squared. Now, if you look at this really carefully, this really says 3x times the natural log of x squared. I don't just have a 3 in front. I have a 3 and an x. That has a variable. And it's being multiplied by the natural log of x squared that has another variable. So to me, this looks like two functions with variables in them that are being multiplied together. And the only way that I can find the derivative of two things being multiplied is by doing product rule. Now within that product rule, I'll have to use my natural log and my chain rule, but this originally starts as a product rule. Product rule says, do you remember? The first times the derivative of the second, so the derivative of natural log of x squared is the derivative of the inside over the original inside. That's the first times the derivative of the second, plus the second times the derivative of the first, and the derivative of 3x is 3. I can go ahead and combine those fractions. I have a 6x squared on the top over x squared on the bottom. You might notice that the x's on top reduce with the x's on bottom, so I'm just left with a 6 plus 3 times the natural log of x squared. You'll notice that I didn't add the 6 and the 3 together and call that a 9 because the 3 has a natural log of x squared attached to it. It's not like terms. It's not the same as just a regular 6, so you cannot put those together. All right, look at C with me. C has 2 times the natural log of 3x on the top in the numerator, and then I have a 5 plus 3x in the bottom. Please, 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 please do not try to reduce and cross off the 3x on top with the 3x on bottom. The 3x on top is attached to the natural log, and the 3x on bottom is attached to that 5 with that plus sign. So you cannot reduce those off, okay? It wouldn't make sense mathematically. So it looks like what we have is a quotient rule. Don't we have variables in the numerator and variables in the denominator? And I don't know about you, but I don't know how to simplify this anymore. So it looks like we're going to have to do a quotient rule. But before I did the quotient rule, I noticed that there was just a 2 out here. And isn't that the same thing as doing 2 times the natural log of 3x over 5 plus 3x? If you think about it, and you put that 2 over 1 and you combine them, you would get your original equation. So why can't I separate them? As long as that 2 is just a number and it's just a coefficient, I should be able to take the 2 over 1 out. Now I can't rip away the 5. I'm not going to pull out a 2/5. I'm just going to take out a 2 because it's just a constant in front. So our rule from a long time ago, it seems like, says that we can take that 2, keep it out in front, find the derivative of the rest of my problem, and then multiply it back by 2. All right, so here we go. The rest of the problem still looks like a quotient rule. So quotient rule says the bottom times the derivative of the top, and the derivative of natural log of 3x is 3 over 3x. That's the derivative of the inside over the inside. That's the bottom times the derivative of the top. Minus the top times the derivative of the bottom, and the derivative of 5 plus 3x is just 3. Over, don't forget, your bottom squared. Now we can simplify a little bit. You notice that I reduced the 3's in the numerator and denominator there. And so then I have a 5 plus 3x in my numerator and just an x in my denominator left. Over in that second fraction, I have a 3 times a natural log of 3x. The denominator there is really just a 1. But I have my other denominator of the 5 plus 3x squared. So be careful. If you're looking at this, you have a 5x plus 3 over x minus 3 times natural log of x over 1, technically, right? And then all of that has its own super denominator. But we don't like it, do we? We don't like that triple layer fraction. So what we're going to do is we're going to actually combine those two top fractions and try to just get it into a numerator and a denominator instead of a triple layer fraction. But before we can do that, and before we can subtract these fractions, we need to have a common denominator. So it looks like this fraction is missing an x. So I'm going to put an x on the top and an x on the bottom. When I do that, I would have a 5 plus 3x minus 3x times the natural log of 3x all over my common denominator of x. But remember, there's that super denominator that we had to divide by. And that would still give us 3 layers, right? Unless, instead of dividing by the 5 plus 3x squared, we actually multiplied by his reciprocal. We've seen this in the past, haven't we? Instead of dividing is the same thing as multiplying by the reciprocal. So I could really multiply by 1 over 5 plus 3x squared. That allows me to put numerators with numerators and denominators with denominators and just have one fraction with a numerator and a denominator. So on the top, it looks like I have a 5 plus a 3x minus 3x times the natural log of 3x over the x times the 5 plus 3x squared. Don't forget you still have that 2, that coefficient in the front. You could, I guess, distribute the 2 to everything in the numerator in the top if you wanted to and call it a 10 plus 6x minus 6x natural log of 3x if you wanted to. Or you can leave the 2 out in front. Either way would be okay with me. Whew, that was kind of a complicated problem. You have to be really careful on that one to be able to see all the little pieces on that.